हॅलो डिअर स्टुडंट्स, वेलकम बॅक. गणित मित्र या चॅनलमध्ये पुन्हा एकदा तुमचं स्वागत आहे. आज आपण 12वी सायन्सच्या ट्रिग्नोमेट्रिक फंक्शन या चॅप्टरमध्ये पुढचा पॉईंट सुरू करणार आहोत, जो आहे सोल्युशन ऑफ ट्रायंगल. याच्यामध्ये पहिलेच आपल्याला 3 महत्त्वाचे पॉईंट डिस्कस करायचे, ते म्हणजे साइन रूल, कोसाइन रूल अँड प्रोजेक्शन रूल. पण त्यापूर्वी सोल्युशन ऑफ ट्रायंगल म्हणजे काय आधी आपण डिस्कस करू. What is actually solving a triangle? So we all know that a triangle has 3 sides and 3 angles. We call them as elements of the triangle. If any 3 elements are known, in which at least one of the element must be a side, okay, then we can determine other remaining 3 elements of that triangle. So solving a triangle means to find unknown elements of triangle with the help of known elements of the triangle. Now we are going to consider following standard notations. Look at this diagram. Consider this triangle ABC. Now BC is exactly opposite to the angle A. So we call length of BC is small a. Similarly, this AC is exactly opposite of angle B. So we denote its length by small b. Similarly, the length opposite of angle C is small c. Also, we denote angle of a triangle by the letter respective to the vertex of the triangle. It means if I want to denote angle ABC, then I will call it as just B. So B represents angle ABC, or most of the times it is measure of angle ABC. So these are the notations for the convenience. Similarly, this C represents measure of angle ACB, or this A represents measure of angle BAC. So we denote small letters ABC for the sides and capital letters ABC for angles. Okay, so we refer all these notations as usual notations in further discussion. Now let us move to the very first theorem, that is the sine rule. It is stated as in triangle ABC, A upon sine A is equal to B upon sine B is equal to C upon sine C, which is equal to 2R, where R is the circumradius of the triangle ABC. Or in other words, this can be stated as sine of an angle of a triangle is proportional to the length of the side opposite to it. Now we are going to prove this statement. Now this proof is divided into two parts. Proof of first 3 equalities. This is the first part of the proof, and the second part is it is equal to 2r. Okay, so let us start with this first part. For that I am going to consider a triangle ABC. Obviously this side BC is A, then this side is B, and this side is C. Now I'm going to draw a perpendicular from the point A on the base BC. So it will be the height of the triangle. We call it as AD. So let me write, let AD is perpendicular to BC. Now if we consider the triangle ADC, then what is the sine C? Sine C will be opposite side AD upon hypotenuse AC. So AD upon AC. Therefore, AD can be written as AC sine C. If I take AC here, it will be AC into sine C, and therefore I am going to write AD as, now look at here, AC means length B, so it is B sine C. You can call it as equation 1. Now therefore, area of triangle ABC, what is the standard formula? It is 1/2 base into height. Base is BC into height is AD. So which is equal to 1/2 base BC. It means the length A, okay, and AD. AD means B sine C. You can write it from 1. Okay, so therefore 2 times area of triangle ABC is equal to AB sine C. Now look at this diagram. If I shift A to this place and this C to this place and this B to its next, means this place, okay, then this triangle will be like B A C. And if I follow the same procedure, I can prove 2 times area of triangle ABC is equal to BC sine A. And if I make similar rotations one more time of these vertices, I can prove that 2 times area of triangle ABC, it is equal to AC sine B. Now observe these three equations. Their left hand side is equal. It means all these terms on the right hand side are also equal. So I'm going to write it here. To maintain the sequence, I'm going to write initially the term of sine A, BC sine A, it is equal to AC sine B, it is equal to AB sine C. Now I'm going to divide by ABC to all these three terms. So I can write BC sine A divided by ABC, which is equal to AC sine B divided by ABC, and which is equal to AB sine C divided by ABC. Now if we divide by ABC, this BC will cancel with this BC, then AC will cancel with this A and C, and AB will cancel with this AB. Therefore we can write sine A upon A is equal to sine B upon B is equal to sine C upon C. And therefore by just taking reciprocal of all the terms, we can write A upon sine A, which is equal to B upon sine B, is equal to C upon sine C. Okay, so this is the proof of this first part of sine rule. Now in the next part we are going to prove this is equal to 2R. So let us move to the next part. I am going to use the same triangle. Say suppose triangle ABC. Obviously this side will be A, this side will be B, and this side is C. Now I am going to draw the circle such that it passes through all the three vertices. Look at here, this red dot is the center of that circle, and this circle is passing through A, B and C. So that is why this circle is called as circumcircle of this triangle. This center of the circle is circumcenter. Let us call this center as O. Now radius of that circle is called as circumradius, and it is given as R. So in this case circumradius is given as R. Now for any triangle, sum of all the angles is 180 degree. It means it contains at least one of the angle which is not right angle. All three angles cannot be 90 degree, or two angles cannot be 90 degree. Okay, so there must be one angle which is not a right angle. So let in this case angle A is not right angle. Now I am going to draw the diameter from that vertex A, and let that diameter meets the circle at the point P. So we can write AP is diameter, and therefore what is the length of AP? It is twice the radius, so it is 2R, because circumradius means the radius is OA, or you can say OP is R, and therefore diameter is 2R. Now this diameter splits this circle into two parts or two semicircles. We know that angle inscribed in a semicircle is a right angle. Okay, so I'm going to make use of this property. So for that I'm going to draw line CP and consider this angle ACP. Okay, which angle? Angle ACP. So this is the angle inscribed in a semicircle, and therefore angle ACP is equal to 90 degree. So we can write the value of sine P. So what is the sine P in this case? Sine P is opposite upon hypotenuse, म्हणजे AC divided by AP. AC divided by AP. So we can write this is equal to AC is side B, and what is AP? AP is diameter, which is nothing but 2r. So you can say sine P is equal to B upon 2r. Now I'm going to use one more property. See this AC. AC is the chord of that particular circle, and these angles, look at the angle APC. I have highlighted by red color. So angle APC, and the another angle I have highlighted it by blue color, ABC. Angle ACP and angle ABC both are inscribed by this chord in the same arc. Okay, and both are lie on the same side of that chord. Okay, so I can write angle APC and angle ABC are inscribed in the same arc. Therefore, I can say angle ABC is equal to angle APC. Look at it, I'm going to repeat the property. These both angles are on the same side of the chord and they are inscribed in the same arc, and therefore they must be equal. So I'm going to write angle B is equal to angle P. So in short, I can write again angle B is equal to angle P. So if I take sine of both angles, then sine B is equal to obviously sine P. But what is sine P? Look at here, sine P is B upon 2R. So this is nothing but B upon 2R. You can call this particular term as 2 because I used number 1 in the previous part of this theorem. So I am going to use this as 2. And from 2, so sine B is equal to what? B upon 2R, and therefore I can write 2R is equal to B upon sine B. Okay. Now previously we have proved that A upon sine A is equal to B upon sine B is equal to C upon sine C. But B upon sine B is what? 2R. Therefore all these three are equal to 2R. Okay, and hence the proof. This completes the proof of sine rule. Please repeat this proof, both the parts, and try to remind all these things. Okay. Let us move to the next point, which is different forms of sine rule. Initially we have stated that A upon sine A is equal to B upon sine B is equal to C upon sine C. This is equal to 2R. Okay. Now this can be modified as sine A upon A is sine B upon B, or it is also sine C upon C, just by taking reciprocal. So it will be 1 upon 2R, but you can call that 1 upon 2R as some another constant, say suppose K. So this sine rule can be stated or used in this form also, or we can use the sine rule in this third form. If we consider these two are equal, then we can write A sine B is equal to B sine A. If we consider second and third are equal, then you can write B sine C is equal to C sine B. Or if you consider the first and third are equal, then A sine C is equal to C sine A. Okay, so this is the another form. We can use sine rule in this form also. Further, we can modify A is equal to 2R into sine A. Okay, look at here. See, consider this first original statement. Now consider this first part is equal to 2R. Omit these two. So you can write A is equal to 2R and take sine A to this side, 2R into sine. Similarly, B is equal to 2R into sine B. or C is equal to 2R into sine C. Okay, or we can also write, look at here, if I consider these two terms only, omit these two, take B to this side, so it is A upon B, and sine A to this side, it is sine A upon sine B. So it is A upon B is equal to sine A upon sine B. And similarly, if you consider these two, it will be like B upon C is equal to sine B upon sine C. So these are different forms of sine rule. Let us move to the next rule, which is the cosine rule. Cosine rule is stated as, in triangle ABC, A square is equal to B square plus C square minus 2BC cos A. If I take this type of shifting, replace A by B, B by C, and C by A. A by B, B by C, and C by A. Similarly here, B by C, C by A, and also have the same replacement for the capital letters also. So capital A by capital B. So you get the second formula, B square is equal to C square plus A square minus 2CA cos B. If you take one more replacement or shifted A to B, B to C, and C to A, you get one more formula like C square is equal to A square plus B square minus 2AC cos C. Okay, now in the proof of this theorem, we are going to prove the first statement, A square is equal to B square plus C square minus 2BC cos A. For that, consider this particular diagram. Consider A as a origin, then side AB along the x-axis, and line perpendicular AB through A, it is the y-axis. So obviously coordinates of A will be 0, 0, and coordinates of B will be, look at here, this is opposite of vertex C, so this is small c, so this distance is C, so coordinates of B are C0, they are written here. Now how to find out coordinates of C? How they are B cos A comma B sin A? For that we are going to make use of the concept of polar coordinates. Recall that if the point pxy are the Cartesian coordinates and p r theta are the polar coordinates, where r is what? Distance of the point from the origin, and theta is this particular angle. Now in this case, the distance of point C from the origin is B. Look at here, the distance is B. Okay, and what is the theta? Theta is this angle. This angle is A. Okay, so you can call it as A. Okay, if it is given, then we write polar coordinate as P r cos theta, r sin theta. Okay, so in this case it will be point C, r is B cos A, and r is again B sin A, because theta is A here. So this is how these coordinates are B cos A and B sin A. So you can write also C is equal to B cos A, B sin A. You can write this explanation also, no problem at all. Now we are going to prove this part, A square is equal to B square plus C square minus 2BC cos A. For that, consider A square. So what is A actually? A is BC. So it is actually BC square. Okay, now by using distance formula, what is BC square? If you use distance formula, it will be like subtraction of x coordinates C minus B cos A, in the first bracket C minus B cos A square plus 0 minus B sin A square. Actually there is a under root sign in the distance formula, but when we are taking BC square, because we are taking square, that root sign will be gone, and we are writing just C minus B cos A square, that is subtraction of x coordinate bracket square and subtraction of y coordinate 0 minus B sin A bracket square. Now let us simplify. This will be C minus B cos A, means A minus B bracket square formula, C square minus 2BC cos A plus B square cos square A plus here also B square sin square A. because 0 minus b sine a is actually minus b sine a, but its square becomes plus b square sine a. Now you can easily identify that we should take b square common, so cos square a plus sine square a becomes 1. So c square minus 2bc cos a plus b square cos square a plus sine square a. But as per the fundamental identity, cos square a plus sine square a is equal to 1, so I can write b square into 1. So it is actually b square. So I am going to rearrange the terms. B square plus c square, b square plus c square minus 2bc cos a, which is nothing but the a square. Okay, and this is what the actual we want. Okay, so hence the proof. To get it, this is the proof for first statement. A square is equal to b square plus c square minus 2bc. Now if you want to prove the second statement and the third statement directly, we can prove next two statements by just replacing the positions of A to B, B to C and C to A. If you shift these positions, then there will be new values of these coordinates, and if you use the same method we can prove this next one. Or again, if you take one more rotations of these vertices, you can prove the third one. You can write similarly, we can prove b square is equal to c square plus a square minus 2ca cos b, and c square is equal to a square plus b square minus 2b cos c. Okay, so we can write next two statements just by writing similarly and so on. Let us see some more forms of cosine rule. Now originally we said that a square is equal to b square plus c square minus 2bc cos of a. Okay. Now I can modify this particular statement by simplifying or adjusting some terms. I am going to take 2bc to this side, so it will be 2bc cos of a, and taking a square to again right side, so it becomes b square plus c square minus a square. Okay, so just shift this b square to left side, a square to right side. So therefore cos a is equal to, what is cos a? B square plus c square minus a square upon 2bc. Okay, see, so this is the another form of cosine rule. You can express the same statement in the form cos a is equal to b square plus c square minus a square upon 2bc. Okay, or you can represent the another statement as cos b is equal to c square plus a square minus b square अपॉन 2ca. लक्षात घ्या, cos b आहे म्हणजे इथे मायनस बी स्क्वेअर असणार, इथे मायनस बी स्क्वेअर म्हणजे इथे सी स्क्वेअर आणि ए स्क्वेअर असणार आहे, असं काहीतरी आयडिया करून लक्षात ठेवायचं. आणि इकडे सी आणि ए आहे, याचा अर्थ इथे 2 टाइम्स सी. ओके, और यू कॅन राइट थर्ड वन cos c. cos c म्हणजे काय, इथे मायनस सी स्क्वेअर असणार 100%. सो दॅट इज वाय इट इज बी स्क्वेअर प्लस ए स्क्वेअर, और यू कॅन राइट ए स्क्वेअर प्लस बी स्क्वेअर अपॉन 2ba और 2ab. ओके, सो हे आपण वेगळ्या फॉर्म मध्ये कोसाइन रूल मांडू शकतो. लेट अस मूव टू द नेक्स्ट पार्ट, दॅट इज द प्रोजेक्शन रूल. प्रोजेक्शन रूल काय सांगतो बघा, इन ट्रायंगल ABC A इज इक्वल टू B cos C प्लस C cos B. आता A लिहिताना B आणि C चा यूज करायचा, सो B cos C and C cos B. Okay, then B is equal to C cos A plus A cos C, and C is equal to A cos B plus B cos A. Now I am going to prove the projection rule. The very first statement, A is equal to B cos C plus C cos B, and after proving this first statement we can write similarly the B is equal to, that is the second statement, and the third statement C is equal to. Okay, so the proof of the first one. Now consider this diagram first. Okay, let the altitude drawn from the A which meets BC at the point D. Okay, A पासून एक altitude काढली. The altitude means it is 90 degree. It is perpendicular to the BC. Okay, it meets BC at D. So AD is the perpendicular to BC. Therefore, this BD, see, this BD is called as projection of AB on the line BC. Okay, so for that, let us consider this is a flat surface and this is a wall, and if you place a stick like this, okay, and if there is a lamp and the light is coming exactly perpendicular, then how is the shadow of this particular stick? Then shadow will be like this. Alright, so that is why we call it as a projection. Okay, so या स्टिकचा इथे आपल्याला बरोबर शॅडो पडणार बघा अशीच. जर बरोबर परफेक्टली अशा पद्धतीने जर आपल्याकडे लाईट आपण जर परपेंडिक्युलर लाईट जर इकडे फेकला तर अशी जर स्टिक असेल एखादी तर त्याची शॅडो कशी पडणार आहे तर अशा पद्धतीने आपल्याला जमिनीवर पडलेली दिसणार आहे. ओके, म्हणजे हे त्याचं एक प्रकारे प्रोजेक्शन झालं असं आपण म्हणतोय, लक्षात घ्या. ओके, सो सी सेम सिच्युएशन. AB is the line and BD is the projection of AB, okay, on this flat surface BC. Similarly, DC is what? Projection of this AC. Okay, so I can write. आता आपण या कन्सेप्टचा यूज करणार आहोत. Now we are going to divide this proof in 3 different cases. The case 1, where angle B and angle C are acute. Actually, these 3 cases are on angle B. Angle B is acute, or angle B is obtuse, or angle B is right angle. Okay, now consider in triangle ABD. What is the value of cos B? See, ABD. What is the value of cos B? It is adjacent upon hypotenuse, so it is BD upon AB, or you can say BD is equal to AB cos B. But what is actually AB is? AB is C cos B. Similarly, in triangle ADC, or you can say ACD. Okay, what is cos C? Cos C will be like adjacent upon hypotenuse, so adjacent DC upon hypotenuse AC. Therefore, what is the value of DC? DC is equal to AC cos C, or what is AC now? AC is B cos C. And here BD is C cos B. Now look at here, BD is actually projection of AB on BC. So the first projection is C cos B. And what is DC? DC is projection of AC on BD. So it is DC B cos. Now if we write A is equal to, that is length A is the whole length BC. Okay, so it is actually BC. But what is BC? It is BD plus DC. But what is BD? BD is C cos B. And what is DC? It is B cos C. Okay, and therefore, and which is nothing but A. And therefore, we can say A is equal to C cos B plus B cos C in the case 1, in the first case. Okay, look at here. Why this rule is called as projection rule? Because that particular length A can be written as the projection BD and projection DC. So A is actually addition of 2 different projections. So it is why it is a projection rule. Okay, try to understand the concept of projection here. Okay, now let us consider the case 2, where B is an obtuse angle. Okay, now for that consider this diagram. B is an obtuse angle, C. Then rest of 2 angle must be acute. Okay, so C is obviously acute. Now in this case, what happens if I draw a perpendicular AD? Okay, if I draw a perpendicular AD to the BC, I have to say BC extended. So extended part of BC. Okay, it meets the extended part of BC here. Now look at here, this angle is B actually. This is the part of the triangle ABC. So this angle is B. So what about this angle is what? This is 180, so it is pi minus B. So in triangle ABD, what is the cos of pi minus B? I'm going to find out cos of pi minus B. Cos of this angle pi minus B is adjacent side DB upon hypotenuse AB. Therefore, what is DB? Therefore, we can write what is cos of pi minus B? Pi minus B means second quadrant in which cos is negative. So it is minus cos b. Minus cos b is db upon ab. Therefore db is equal to ab into minus cos b. But AB is C, so it will be minus C cos B. Why? Since AB is C. Okay, so DB means what? It is actually projection of AB. Okay, DB is what? Projection of AB. It is minus C cos B. Similarly, now I am going to consider bigger triangle ADC in triangle ADC. What is the cos C value? What is cos C? Cos C will be adjacent side DC upon hypotenuse AC. Okay, so DC is equal to AC cos C, but DC is equal to what is AC? AC is B cos C. Can I call DC as projection of AC? Yes, it is projection of AC on the baseline. So DC is projection of AC. Projection of AC, which is actually DC, which is B cos C. Okay, now I'm going to find out the value of A. A is equal to what? BC. But what is BC? It is actually DC, the whole DC minus DB. That is subtraction of these two projections. DC is what? B cos C minus what is DB? DB is minus C cos B. So that minus minus becomes plus. Therefore, you can say A is equal to B cos C plus C cos B. So this is the proof in the second case, case 2. Okay, now there is one more case, case third. What happens if this B is right angle? Draw this diagram, a rough diagram. A, B, C. So pardon my sketching. Okay, let this B is equal to 90 degree. Now see, in this previous case, we draw the perpendicular from A, which meets at the base at point D. Okay, somewhere outside, or in the first case, it is exactly inside the BC. Okay, but in this case, if we try to draw the perpendicular from A, it exactly meets at the point D. So B and D actually coincides. Okay, now I am going to prove this part by using the right side. Okay, now in this case I am going to use the right side and we will prove this is equal to A. So now initially, as B is right angle, we can say cos B is equal to what? Cos of 90 degree, which is equal to 0. Also, what is the value of cos C? As usual, what is the value of cos C? Let me write. This side is A, this side is B, and this side is C. What is the value of cos C? It is actually adjacent upon hypotenuse. So it is A upon B. A is equal to B cos C. Okay. Now consider the RHS. RHS is what? B cos C plus C cos B. This is equal to B cos C plus C into 0, because cos B is equal to 0. Therefore, this is equal to B cos C. But what is B cos C? B cos C is A. So this is equal to A. From 1, you can say 1. Okay. And therefore, you can say this is equal to LHS. So in this third case, case number 3, we have proved that this right hand side B cos C plus C cos B is actually equal to A, and hence the proof. So we can write from all the cases 1, 2 and 3, A is equal to B cos C plus C cos B. That's all. This is the proof for this statement. So similarly, we can prove the statement for B and statement for C. This is the proof of projection rule. Now, if you understand this proof very well, then you can easily understand why this theorem is called as, or why these three properties are called as projection rule. Okay, because one side is presented in the sum of projection of two other sides. So these three are very important theorems in the chapter solution of triangle, and we are going to use sine rule, cosine rule and projection rules various times to solve different type of example. Thank you. And finally, if you really want to appreciate this work of making this PPT, representing it, recording, presenting to you in the form of this video, please like this video, share and subscribe. That's all for today. Bye bye.